Hello guys, today we're going to continue factoring. More specifically, we're going to be factoring complex trinomials. So do not get freaked out by the complex trinomials. They're exactly like the factoring trinomials. You just have to do a couple more checks in terms of your answer to make sure you factored correctly. So speaking of reminding yourselves, make sure that you complete the entry test. This is really just for your guys' selves to see if you can remind yourself on what we worked on in the last class or in the last remote learning. So make sure that you do those on your own. You will be graded, and you will be graded on those on your guys' notes. So let's start with two problems that we covered. These are both trinomials. Now, I did not give the name simple trinomials last class period, but notice that these are simple. The main reason they're simple is because if you look at the coefficient in front of the m squared, there's no coefficient, so technically is they 1. The same thing with the second problem here. If you look at that n squared, its leading coefficient is also 1. That is what is called simple trinomials because they're a little more simpler. I wouldn't even say simpler. There's just a little less things to think about when factoring these. I'm going to give you two examples of simple trinomials, and then we're going to go into ones that are not as simple. They're a little more complex. So here I notice that I have three terms. There's no greatest common factor I could take out. So I know that this might be able to factor to two binomials. Now, knowing the patterns of multiplying two binomials that was covered in the last video, I know that the first two terms multiply to the first term of what I'm trying to factor. So what times what is m squared? M and m. Now remember that these last two terms here multiply to my last term of my trinomial that I'm trying to factor. So I need to think of things that multiply to 10, aka factors of 10. So I'm going to write down my 10. I always like to do this because I'm a very visual person, so I like to do everything on paper, not just in my head. So here is 10. What are things that multiply to 10? It's 10 and 1, 5 and 2, and I think that's about it. Now, why did I write down all the factors? Because this is where things get a little bit more, I wouldn't even say tricky, you just got to think about them a little more. Remember that when those two blues multiply to 10, you also need them to add up to the middle term, that negative 7. So looking at all my factors, which one of these add or subtract to 10? I have 10 and 1. There's no way I could add or subtract those to 7. I have 5 and 2, which add up to 7. So that means that those are my factors. Now, this is a little bit tricky because notice I need them to multiply to a positive 10. See how that guy's a positive 10? 5 times 2 multiply to a positive 10, but they don't add up to a negative 7. Remember that if you have two negatives multiply to a positive, and they also add up to a negative. So that means that my factors are actually negative 5 and negative 2. If I were to multiply this out, notice that you would end up with m squared minus 7m. And that is why these are a little bit simpler, because they're very straightforward in terms of filling out what you need in terms of your two binomials. Whenever you have a simple, all you're thinking about is, hey, 1 multiplies to a positive 10, but adds up to a negative 7. You don't even really have to think about that 1 out there because it just kind of plays out itself. And I'll show you in a second where it doesn't. So let's go on to the next one. Again, I have a trinomial. I've already tried to take out the greatest common factor. There isn't one. So I know it's going to factor to two binomials. The first two terms have to multiply to the first term of my trinomial. So what times what equals n squared? That would be n. Notice that the last two terms have to multiply to a 7, but also add up to a negative 5. So let me go here and write down my factors. 2 times 2 multiplies to 4, and then 4 times 1 also multiplies to 4. Which one of these add or subtract to a 5? I believe it would be 4 and 1. Keep in mind that I really didn't even think about negatives and positives just yet. All I'm worried about is, hey, what adds and subtracts to 5? Now I can bring back the negatives and positives. I know I need to add up to a negative 5, so both of them have to be negative. They still multiply to that positive 4, and then are okay. So that means that those are my factors, negative 4 and a negative 1. So if you were to multiply those out, again, you would end up with your original trinomial. Now, this is where things get a little more complicated in terms of trinomials, more complex. Notice that if I tell you to factor these two in the bottom right over here, I'm on this section, by the way, I have a 3 and a 7. So things are not quite as easy as they seem just yet. Now, don't think that it's so complex that things are going to be impossible. It's just you have to take your time a little bit more and also kind of play this as a puzzle, because that's all these are. You're trying to figure out what works in order to end up with whatever you're trying to factor. So let's start with this first one. There is no greatest common factor. There's nothing that divides 3, 13, and 10. So nothing there, but it is a trinomial. So I might factor out to two binomials. Now I can see that here, this is not a simple trinomial because my leading coefficient there is a 3. So remember, nothing really changes. You need to be thinking about, okay, what times what multiplies to 3x squared? So what I'm going to do here is write down my 3 and write down the factors. 3 and 1 is the only factor because it is prime. So that means that these two first terms have to be 3x and 1x. Notice I left the 1 out because there's no reason because I have that x. If I were to multiply these two binomials, 3x times x would be a 3x squared. So let's move on now. So my changing still hasn't changed much from the simple trinomials, and nothing's going to change just yet. I know that these two terms multiply to a negative 10. So I'm going to write my negative 10 over here. Now, before I start worrying about negatives here, I'm just going to worry about things that multiply to 10. Things that multiply to 10 are 10 and 1, 5 and 2, and I believe that is it. Now, notice that if you were trying to add these up, none of these add or subtract to a negative 13. Now, this is where the complex comes into hand. You just can't look at your factors and then see which one adds or subtracts to negative 13. It's a little bit more challenging to that, but not crazy amount. You have to try all these factors and kind of play the game of multiplying here. So if you know how to multiply binomials, it's going to be easy. If not, you're going to be a little bit challenging. So let me show you what I mean by this. This could be a factor. This could be a factor. Let's see if this factor works out first. So I'm going to put my 5 and my 2. And this is what I mean about adding up to negative 13. This is where things get a little bit complex. If you were to multiply these things out, 3x times 3x is 3x squared. Continue multiplying out. I'm going to change these colors so that way you see a little bit what I'm trying to point out here. Do purple. 3x times 2x is a positive 6x. Continuing 5x, or 5 times x is a positive 5x. And then that 5 times 2 is a 10. So keep in mind, what are we trying to add up in the middle? We're trying to add up that single x here. So I'm really worried about those two terms. That is what you have to figure out. Notice that you're ending up with a 6 and a 5. There is no way, shape, or form that 6 and 5 can add up to 13. So that means that you have to try a different combination. So pretty much this is all it is. It's a guessing game. But trust me, the better you get at these, the better strategies you get, and the quicker you'll be done. So notice that 5 and 2 didn't work out. So what I'm going to do is flip them the other way, 2 and 5. Now, you don't have to multiply the first and the last one because, again, you know that those multiply to 3, you know, and the last one's multiplied to negative 10. What you worry is about what the insides add up to. So kind of a quick way of doing it. Let me change color so you can see it. Let me do that green. You're worried about what those two multiply, the two insides. 2 times x is 2x. Multiply the outsides. 3 times 5x is 15x. Do these add or subtract to 13? And the answer is yes. They would subtract. Which one would you need to be negative? Well, I needed to add up to a negative 13, so that means I would need a negative 15. Which ones are involved, or which two terms are involved in multiplying these? It would be the 3x and the 5. That means your 5 would be negative. You need this 2 in the right here to be positive, so that means you would have a positive in the 2. Now, this gets confusing at the beginning. I know that's why I try to do colors, but the more you practice these guys, the better you will get at them. If you were to multiply these out, you will end up with 13x, or 3x squared minus 13x minus 10. So let me try another example so that way you can see it from beginning to end and see what strategies you need to do and kind of just do the mechanical way. So this is a trinomial. There's no greatest common factor. So I'm going to go ahead and try to just factor out using my trinomials. Now, what multiplies to 7b squared? So here's my 7. My factors 7 are 7 and 1. So that one was kind of easy because you only have a 7 and a 1. Now, what multiplies to 24? Now, if you're like me, you're probably thinking, man, there's a lot of things. 24 and 1, 8 and 3, 6 and 4, 2 and 12, and I think that is it. Now, of course, I know what you're probably thinking. Man, do I have to try each and every single one of these? Technically, if you don't find it by luck the first time around, yes, you have to try these. You have to switch them within the parentheses. But kind of a rule of thumb. I don't know why it works out mathematically, but the numbers that are closer together, like 3 and 8 and 6 and 4, always tend to work out a lot faster. So numbers that are closer to each other, for some reason, tend to work out. So notice I have my 7b and my 7b, my b. I'm just going to try 6 and 4 to see if it works. So there's my 6 and 4. If I were to multiply the insides, I end up with 6b. If I multiply the outsides, I end up with 28. B. there is no way that 6b and 28b are going to add or subtract to 29. So that means that I am going to try another combination. Now remember, if you flip these, they're going to give you different numbers. So make sure you flip them as well to test it out. So you end up with 4b multiplying the inside, multiplying the outside, you end up with 42b. No way that's going to add up to 29, so that means that that is incorrect. I have to try something else. Now, if you have a pencil, that's I highly recommend because you can erase just like the way I'm doing on this board. So let's try 8 and 3. Here is 8 and 3. These multiply to an 8b. This multiplies to a 21. Do these add or subtract to 29? They add up. So that means I have finally found my solution. I found it. So that means that I could go ahead and figure it out. Now, both of these multiply to a positive. If they multiply to positive, they both have to be positive, both negative. Since I'm adding to a positive, that means that they're both positive, and that is your factoring form. So that's pretty much all that factoring complex trinomials pretty much take. Is just you just got to take your time a little bit more. So notice I'm leaving these out for a second. I'm going to go straight up to what says super complex trinomials because I want to show you guys what makes these super complex in a way. And I wouldn't say they're more complex, there's just more options to try out. So let's look at this first one. Notice that there is no greatest common factor that you could take out. Since there is no greatest common factor, I'm going to try to factor it out to two binomials. Now remember, the first two multiply to 4 and squared. So what are things that multiply to 4? Well, it's 4 times 1 and then 2 times 2. Now remember that the last two multiply to 28, so what are factors of 28? On the top of my head is 28 times 1. I also have 14 and 2. I also have 7 and 3. 7, 14, 21. Nope, 7 times 4. Forgot my multiplication effects there. So those are all my factors. Notice that there's a lot of combinations that I could try. I can start with my first 2 and the 4 and the 1, the 2 and the 2, and go. So what I'm trying to get at is, although this seems overwhelming, just try one at a time. Always try the ones that are closer because those seem to work. So on this side, I'm going to try 2 and 2. So that means that these two could be 2x and 2x. And I'm just going to start going through these. Let's try 7 and 4. So here is 7 and 4. The insides multiply to 14x. The outsides multiply to 8x. Add those up. What is 14 plus 8? I think it would be 22. It would be. So it's not exactly our 23. Unfortunately for us, that did not work out. So let's go ahead and try some other ones. Let's try to flip those to see if those work. So I'm going to make this a 4 and a 7. Let's see. 4 times 2 is 8x, and then 2x times 7 is 14x. If I were to add these up, they also add up to 2. So I get the same thing there. Notice I probably could have figured it out because I'm multiplying the 2's, but you can see that it ain't always going to work out that way, so you have to try them on both. So that didn't work out. Let's try the other one. 14 and 2. So here's 14, here is 2. The hardest thing is understanding what you're looking for, right? 14 times 2 is 28x. Outside is 4x. They add up to 20, or they add or subtract to 23. And the answer is no. Subtracting would be 24, and then above would be 32. So here I go again. I'm not going to flip them this time because, again, my leading coefficients here are 2 and 2. So it's going to be the same thing. 28 and 1. So here's 28. Here is 1. That is going to be 56. Now I can honestly see right away that 56 and 2 are not going to add. So notice that I did all that work. I've gone through all my steps, but I have not gone through my first coefficient. So that means, unfortunately for me, that I started off late. I know I said that I suggest to always try the ones that are closer, but if it doesn't work, you got to try everything. So let's try 4x and x. Where did I get these numbers? Again, I'm trying that one out. Let me change colors so that way I know I'm not confusing of what I've tried. Start with 7 and 4. The inside is going to be 7x. The outside is going to be 16x. Now do 7x and 16x add or subtract to 23? And the answer is yes, they would add up. Let me double check. Yeah, 7 plus 16 is 23. So that means I have finally found my solutions. Notice that these things are not very hard. It's like puzzles, right? Are puzzles hard? Not really. You just got to be patient and make sure that you test all your solutions. So I have to multiply to a positive, but also add up to a negative. So that pretty much tells me that they both have to be negatives because they have to add up to that negative. They have to add up to that negative there. So that's pretty much all you have to do for complex trinomials. Now, I was going to have you guys do the greatest common factor too as well, but I feel like it's a little bit too much. especially before a break. So if you guys have an idea of how to do complex trinomials, I'm happy with that. Your homework will not include these problems. They will all be just complex trinomials.